Good afternoon, everybody. My name is Sergio Maffioletti. I'm the current director of the Enhancer project, which I will introduce later on, and working at the Scientific IT Services at the University of Zurich. Today, what? Yeah, you just go ahead. Today, what I'm going to present, it's an effort that we are investing right now. So I'm not presenting a finished solution or a completed experience, but rather the type of effort we are putting into motion within the Enhancer project and within our own university to support researchers, so end user in this case, to ameliorate or to go into the direction of reaching this point of reproducible research and how we use containers for this purpose. So the goal here is not just to present the technical aspect of how the containers are used or how the container operates. You probably know all of this much better than me. It's mostly on how do we build an end user story so that we organize not only a solution, a technical solution, but a service, as they per se, for the end users. Quick disclaimer, what I'm going to present here, it's mostly a personal opinion. And I'm already up to my time. I'm done. Thanks. Cool, that was, okay. It's mostly a personal opinion and the outcome of some discussions within this Enhancer project that I will expand a little bit more afterwards. That means if you like the talk, it's all my benefits. If you don't, blame all the Enhancer project. So what I'm going to talk about, just give a little bit of a context. So what do we mean by using container for reproducible research? And I will try to give you a glimpse of what is the user-side perspective on this. And then, let's say I will share with you some of the thoughts in respect of how do we build an infrastructure support, how do we build competencies and integrate services in order to be able to build containers, not only just run them. And then also what we put inside a container in order to enable reproducible research as a service to a certain extent. And I will try to come up with a list of open questions and main challenges that we think, one way or another, we have to face. The idea is that under the umbrella of this Enhancer project, we would like to have a conversation, let's say a roundtable conversation where we could address those challenges altogether. Enhancer is a Swiss university-funded project that reunite scientific IT services from main academic institutions, up to 8 as of now. The objective is to provide scientific IT services to the entire Swiss academic sector. There are 2 main activities in there. One is just, as I was pointing out, we sit around the table, we share experiences. The other one, we implement community solutions or end-user solution on a specific base. And then one of the topic that we were discussing within this project was indeed how do we, let's say, starting from a technology, from a container technology, how do we use this in order to provide a better experience for the end users? So let me just focus all of this. The idea here is to look into the aspect of the reproducible data analysis. This is really end user side. Why am I looking into this? Because here in the audience and typically within the hpc-ch forum, there are outstanding infrastructure providers. Most of you are infrastructure providers. Many of you might also be part of a scientific IT service unit, whose mandate is not only, well, allow me the term only, it's not only to provide an outstanding high-performance infrastructure, but it's also to provide end-user support and to make sure that the resources are used effectively by the end users. And for this, you need to have a, let's say, try to have a better understanding of also on the user side. So the focus here is on the reproducible research. I'm not reading this, and I'm not asking you to read this. All I would like to say is that there are different attempts to try to give a formalism around the concept of a reproducible research, reproducibility, replicability, repeatability, to my knowledge, there's no such a thing as defined formalism. There are many definitions around it. I think that for the scope of this talk, it's I would use this type of approach, this graphical approach, where most of the sign is slightly changing, but still, many of the current publications, the scientific publication, come up with plots, with table, and everything within the manuscript. Very seldom they include code and data. Now there are scientific fields where this trend is changing, but still nowadays I think it's safe to say that in general this is still the de facto standard for publications. At best, they provide within the publication itself a brief description of what software has been used, how or what methodology has been used. And then this is a little bit the goal, to have, together with the publication, a full working environment that ideally also contains the data, the software, a working software environment, not just a description, that one can take and reproduce the result. Not only reproducing the result, here the idea is also to move forward from that point. What we need to understand is that the idea of a reproducible system is not just to be able to replicate the result. It's also being able to take whatever has been done by that researcher associated to that particular publication, which I particularly find interesting, and move forward from that point on. So I can take the results, I can understand the results, I can reproduce the results, but I can also take them for granted. I don't have to reprove them or come again to the same type of conclusion, invest a lot of time to rebuild all of this. I can move forward from that point on. So let me give you the user side of the story. On average, and here I'm not talking about every researcher or every scientific area, but on average, a researcher tends to develop its own data analytic. A few exceptions, you see that they use legacy code. They tend to develop their own scripting and their own data analytic part. And then most of the time, they do develop on their personal computer. Then the code that they use for the data analytic changes over the course of the time while the data are changing and while the research progresses, because they don't know upfront what they wanted to find, and they have to constantly adapt this. So this idea where I do an initial prototyping of my analytic, and then I run for the rest of my research period the finding and the methodology that I develop during the prototype phase, is not really applying uniformly, let's put it in this way. Then at a certain point, throughout this iteration process, they finally manage to get some publishable results. Go to a professor, they agree, yes, let's publish this, let's write the manuscript. Sometimes they even manage to obtain these results by running on a large HPC infrastructure, something that is not really just their own personal server. That could be their own laptop or could be a dedicated server they have access to. And then they start to prepare the material, the slides, the images, the tabular results, and the manuscripts itself. And then after the review process, they publish. So this is more or less how many are conducting their own research. Of course, it's an oversimplification, but this is pretty much the workflow that many are following. On the other side, and I'm going very quickly on this, this is the message they do receive from the open science movement. We need now to be more open. Open science means not only open access to the data, but also open access to your methodology and so on and so forth. And they receive messages like, you need to be able to share your data and your digital artifacts. You need to be able to provide a persistent link on your digital artifact. Software also needs to be recognized and cited to a certain extent. And you need to, of course, use an open source licenses. You also need to be able to invest your time in documenting your software and your digital artifacts. Pretty big gap in between the two kind of situation. And typically, infrastructure provider and scientific IT service units typically sits in the middle. So what does it mean for us? It means that if we would like somehow to organize a service for end user to facilitate the transition from here to here, we probably need to look a little bit at the full spectrum of the service that's deeper, not only the infrastructure part, but the tools that we need to integrate, the competencies that we need to develop in order to provide a better support, the policies, the practices, and of course, also be able to provide end-to-end support. For the sake of this discussion, of course, skipping the business aspect related to this type of service. Why are we doing this? Well, first of all, by doing this, we might have a better understanding of let's say, of the use cases from the user side. By having a better understanding, we can somehow, from one side, anticipate the problems. The last things we want to do is that we provide an infrastructure where people can run containers, and then you come up with end users' request of being able to run different type of containers formats, different type of containers images that are not validated or certified or things like this. You receive different type of requests that you need to be able to accommodate and support. So by trying to look at the full spectrum and implement solution for the full spectrum, you might try to anticipate a little bit some issues. You can steer the adoption of your services, of your components, of your tools. You can enforce policies, and not simply just denying access to certain ports or certain way of conducting the research, but really making sure that you progressively transform the way the researcher is conducting his research by abiding with this policy, because you provide support for this. And also the plan for the researchers, because by having a better understanding of the user side of the story, you can better formulate how do you want to expand your research portfolio, and not simply by observing that the user requires more memory. You want to have a better understanding of how this memory is going to be used and whether this is the right expansion direction you would like to take or not. At the end, you become an asset for a research group. So you become a partner. The research groups wants to work with you. And this is a value in, let's say, for the whole institution to a certain extent, because you aggregate a little bit the competencies that you make available for the entire research groups within your institution, and at the same time, you spare the individual researchers to go through this stack by themselves. Now, what does this mean? Let's look at the steps that pretty much all of us has to take into account. And we start from the bottom, things that probably you already have addressed. And I'm not going to enter into detail of this. But nevertheless, one start from the infrastructure side. How do we enable container technologies into this, right? And then in order to do this, one needs to choose what container technology, whether we need a container orchestration system, or we need to, do we integrate within our workload management system, whether my storage infrastructure, the storage infrastructure layout suits already the type of container that I want to run and how I want to run it, especially if you think in terms of how the containers images are managed and so on and so forth, or the data are mapped. How do I integrate the container deployment and configuration within my management infrastructure? How do I monitor all of this? This is something that probably you know much better than me. I won't enter too much into detail, but this is a starting point. Once we have let's say, our infrastructure, our in-house infrastructure already supporting the execution of some container technology, then we want to look a little bit in what container I want to allow on my infrastructure. Where do these containers are coming from? Do I want to check and validate the containers that are going to be pulled on my infrastructure? Do I have some mechanism in order to prevent that certain containers are creating a damage within my infrastructure or not? Is it all compartmentalized or not? There, the question is at the level, for example, of the container of the registries. Do I want to have my own in-house registry for the containers to also facilitate a little bit the publishing and the pool of private containers or not? Do I allow any registry to be pulled by by my end users on my infrastructure. How do I verify that that particular container is indeed the one that the user wants to deploy? How do I know that whether the container has the security patch that is not that otherwise will compromise my entire system? How do we know once we deploy the container whether it is indeed running as it is supposed to against the data that the user would like to have? These are all type of questions that one way or another we have, as service provider, we have to be able to address and be able to provide a certain level of support. Last but not least, how do I verify the behavior of the container? If you look into Docker Hub, for example, it's extremely difficult to figure out upfront what a container is supposed to do. There's no systematic container validation procedure for a given container. So when you pull it on your infrastructure, you somehow tried it out whether it works the way it's supposed to or you hope for, or at best, if you have access to a Docker file or to the render script, you can inspect a little bit how it is behaving. But again, here we're talking about academic code. Academic code is seldom documented, is not always very linear in the way it behaves. So also reading the code is not always helpful in this respect. But let's not stop here. Let's not just stop at the, let's say, at the supporting infrastructure. How do I enable containers and what policies do I want to apply in order to allow certain type of containers or not? If we want to provide an end user experience, probably we are going to be faced with the question, can you help me build a container? Or you probably want to encourage users to build containers. So you need to develop a little bit of competencies in building a container. When you want to develop competencies into this direction, I mean, this is a solved problem in the private sector for the software development, continuous deployment, and continuous integration track. So this is nothing new that we do, but it's a type of a competence that probably we wanna develop and we wanna be able to provide to our own end users. Automatic build of containers. Here we also have an opportunity. Let me just take one step back. Academic software. Out of the users that I've been dealing with, I would say less than 10% use our software version control system for keeping track of the software it develops. Here you have an opportunity because if you provide a relatively easy mechanism of integrating software version control system like a GitHub and an automatic build of your container by, for example, specifying within the automated test or by integrating the build within Docker Hub, you also have the possibility to help the user to transition and port its code on a version control system and keep a little bit under control the way the builds are generated. Then also you're facing the question, now every time the user or me together with the user push a new version of this software, a container is generated. How do we name it? What is the naming schema that we want to use? There are many mechanisms, but having let's say an automatic build, you can also transform a naming schema into a rule. So you don't have to keep track of your containers versions separately for this respect. And this is a type of a best practice that you might want to be able to push toward the end users. Not only this aspect, if you're building a container for the user or with the user, you have better possibility of enforcing your site policies or defining your site assumptions. Where do you map the files, where and how you map your file system, for example. How do you automatically build the documentation out of this? How you publish the container together with the specified metadata? What container strategy you would like to use? Whether, for example, you would like to have a single container that contains your scripts, your data, your process, and does everything, very relatively monolithic, but fully self-contained. Whether sorry, the data should come from the outside, and then you have the pipeline encoded within the container. Whether for a sophisticated pipeline, every step of the pipeline is a different container, and then you have an orchestration system that sits outside of this. These are all design strategy that one could take once you reach the point where you can build the containers together with the end users. Then let's make yet another step forward. Now we came to the point where we have our own infrastructure that can run containers. We have a way of building containers automatically with or for the end users, encoding the on-premise assumptions that guarantee that the whole thing works perfectly on my infrastructure and eventually is also relatively portable. Then we come to the point, this is all for scientific code. Very, very few have a clue of what are the software dependencies of their scientific code. Of course, this is probably a problem solved in the enterprise software development cycle, but definitely not in academia. So there, how do we somehow allow or facilitate the tracking of the software dependency for an academic code? It's a challenge to a certain extent, but it's also an opportunity from the others. Depending on the scripting language that is going to be used, but most of the use cases, many I would say, are still based either on MATLAB, R, Python, C, and C++. These are the most that we see around. And for those, developing competence in supporting a conda environment, Packrat, or pip, in order to be able to advertise and let's say, help the user of creating its own virtual environment and keeping the track of the software dependencies within the virtual environment and build the requirement file automatically from the virtual environment. This is an opportunity to establish yet another best practice that comes, that's let's say, a win-win type of situation. The user somehow has an easier way to keep track of software dependencies, and your automated build is facilitated out of this. You don't have to somehow do some magic tricks in order to keep track of of all the possible software dependencies to the best point that you can. Of course, then there are Renku and other type of more sophisticated platforms that allows you to do this type of things. But this is an aspect that has to be taken into account as a type of a competence that one would like to develop as part of the service that you want to offer. Then, questions, because I was mixing up a little bit let's say, the solved problem, things that one way or another we have at hand, and things that probably we still need to discuss a little bit. Let's see, and this is again, this is a preliminary list, and if you see something that is flagrantly missing, I would be very, very happy to know your opinion about this. From the infrastructure side, question is, whether I would like to allow any container to be deployed on my infrastructure or not. How do I make sure that that specific container, the one that is referenced within that manuscript, is exactly the one that I'm going to get? There are different strategies for this, but this is an open question that either within a consortium like an answer or within a community, this probably will have to be organized. How do I verify and validate the container where I deployed on the infrastructure? How do I know that the container is behaving exactly as it's supposed to? How do I know whether the container that I'm getting has the latest security patch that is not compromising my infrastructure? How do I know what the container is doing after all without having to look into the full code of the runner script or all the application that is deployed within there? From the execution side, how do I make sure that the container that I'm deploying run as documented against my data, provided that I have, even if I have a documentation on the container SD per se in terms of what it does, how do I verify whether it is indeed doing what it's supposed to? How do I find the right container? I mean, again, I was pleased to know that some communities are already organizing their own registry, but in the common ones, so take Docker Hub again, it's extremely difficult to be able to find to do a semantic search on containers, right? So I can search for names or some tags or something on this line, but be able to find a container that runs the RNA-seq pipeline, unless it's named like this, and then how can I trust that the container named RNA-seq pipeline is indeed running the RNA-seq pipeline that I'm expecting for? It's still an open question for doing this. Then also, if we look at also from the building side, the building container side, what assumption I can make when building a container, what assumption I should not, so that this container is prevented to be fully portable. In terms of data mapping, for example, the user privileges for another. There's no, let's say, agreed mechanism for defining what assumptions a container should make. I don't know whether within the OCI there is anything, within this open container initiative, there is anything that goes down into this direction. I doubt. But
detail of verifications that no, the OCI does not. But there are efforts from other organizations like Cloud Native Computing Foundation, which is always a Linux Foundation project. Mm-hmm. There are some sub-projects which try to help in this regard.
Yeah. No. I mean, in my opinion, these are questions that drive a little bit your, let's say, your next steps when you're thinking in terms of providing container technology as a service for reproducible research. Where do I publish the container once it is being built, and how do I obtain a DOI, digital object identifier that I can put into my manuscript so that I can also reference it in a way? Again, coming back to the RNA-seq, how do I publish my container so that people can search for it, can semantically search for it, can functionally search for it? And of course, how do I describe and document my container from a behavioral point of view, so people can really understand and can decide based on the description and hopefully also on the verification that the container is behaving as it is described. Two types of challenges that we're facing, and those are probably the most complex one. So the social challenges, the adoption part. How do you convince the user to go through all of this? I mean, they're not paid for learning all of these things. They are not incentivized as of now to go through this. And again, it's not just a matter of willingness. It's also a matter of usability. If you just provide them a piece, a component, and they will have to figure out how to integrate this in their own research development process. Some will do, but most will probably won't. How do you address the question, is it worth my investment? Of course, there are different types of answers to this question. One is if the ability for you to be more visible within your scientific community, because the research that you publish is easily verifiable and people can start from your outcome and build on top of it. It's already an incentive for a researcher, also a research group, especially for a PI that plans the next grant submission. But still, it's something that has to be addressed. Technical questions. So I'm coming back to the integration with the specialized type of resources because, of course, especially with the GPU type of use cases, we do see this as still being at the experimental level to a certain extent. The multi-tenancy, the privilege part, especially when you look into the integration with the HPC system, this becomes a critical aspect. But also the assumptions that are done within the container, so come up with a formal way to describe and document the behavior of the container. The maintenance aspect, so who does the bug fixing, who does the security update of a published container once the researcher that has done all of this has obtained his doctorate and then he simply left. The other aspect is the portability versus the performance. There are some type of use cases where the overhead of the container might still be an issue, and then one would like to decide whether would like to favor the portability of its code base versus the performance that that are required by his use case. And a clear understanding of all of this is something that in many cases is beyond the reach of an average user. So I took too much time. Sorry, Michele. Just a couple of acknowledges. Within this enhancer project that I was mentioning before, we have some simple outcomes. One is the guidelines for the pipeline interoperability. That was it's probably a misleading type of title. This is more a joint experience from different infrastructure provider on deploying container technology and running scientific use cases, and the recommendation that are coming out of this experience, we collected them into this type of document. You can find it on, on the link here. And the other, it's a link to a survey that I would kindly ask you to take a look at. The reason is the following. There are many that are looking into container technology at different stacks. There are few that have a business case in mind, a use case in mind, let's put it in this way. What we would like to do within this enhancer project is to get a better grasp of what is in the mind of the infrastructure provider, what is in the mind of the scientific IT services, and what is in the mind of the end users, and try to have a better understanding of this gap. And this link is a link to a survey for the infrastructure provider. If you have, I don't know, it will take no more than 24 hours. Of course, I'm kidding. I would be really glad if you could take the time to fill up the survey. Thank you very much for your attention.
So I suggest that Jens and Andreas, then Adrian already start setting up their laptop, and so we have time for one question.
Thomas.
Any idea how users can adopt or will adopt?
Speaking. Excuse me, who will start?
Well, I have a personal approach on this. My approach is to work together with them. So, as I said, just you provide this extensive level of support. So you show them that you are already adopting this good practice. You provide the level of support, and then you provide the motivation for them to move. That's a thing that works for us. Doesn't really scale that well because you have to work individually. But that has multiple advantages. Is also having a better understanding of your user base. That's the thing.
This was the question.